This workbook, what we're going to do is work through some of the computations of z-scores. So I'm entering some data in here, test 1 and test 2 from the workbook unit 4. I'm going to enter in the mean in the first test. Before I do that, why don't we put in what my score was on each of the tests. My score on the first test was 92, and the second test was 42. Put in the mean score, the mean for the class, that is, and I'll put in the standard deviation for the class. Now I'm going to make a new row. I'm going to call it the difference from the mean. That is, how much was my score different from the mean score? I'm just going to auto enlarge that column so I can see what I got here. And I'm just going to type in the formula. This cell minus this cell, and that will give me the difference in the mean. And auto-fill it over. There we go. We got the difference in points, in absolute points, from the mean. So I scored 16 points above the mean in the first exam, 10 points above the mean in the second exam. But we need to take variability into account. So to do a z-score, we're going to take that difference and divide it by the standard deviation to get 0.08, or 0.8, I'm sorry, on the first exam, and then in the second exam, we get 2.5. You can see that I just have the difference divided by the standard deviation. And this suggests that I did 2.5 standard deviations better than the mean in the first exam and only 0.8 standard deviations above the mean on the first exam. So, relatively speaking, I did better on the second exam than the first exam, even though I got a higher score in the first exam, even though there were a greater number of, the absolute points were much more different in the first exam. So these other examples in the chapter, I'm just entering the data in the rows. There's the mean, there's standard deviation, there's a score. These are the additional practice. Just get these entered in there. So a score of 125, if I wanted to compute the z-score of that, I just subtract 125 from the mean of 100. I divide that quantity by 15 to arrive at 1.6 repeat. Likewise for 85, 105, and 95. I subtract the mean and divide by the standard deviation. For numbers 5, 6, 7, and 8, I'm just going to copy and paste these column headers so I get an idea of what I'm looking at. The mean and standard deviation, number 5 is 500 and 100. Mean of 6 was 500, mean of 7 is 12, mean of 8 is 12. Standard deviation 5, 6, 7, and 8 was 100, 103, and 1.5 respectively. So the scores I'm looking at are 450, 685, 12.75, and 12.75. Instead of doing the computations, subtract the mean divided by the standard deviation, I'm just going to use the standardized function in this case. The standardized function takes 3 arguments, and that is, it takes the score, the mean, and the standard deviation. And if I enter that in, I get a z-score. Again, this is the standardized function. If I click on the formula bar and help, believe it or not, I get some help, even though it said help wasn't available. And you should be able to see some familiar things here. This is the help function in Excel, or a help window in Excel, and you can see that it provides you with a lot of nice information about the things. You can see the function that it's using to calculate that, and so on. So we'll just X out here and move on. I'm going to autofill this in the case here to get the z-scores of the questions 5, 6, 7, and 8. You'll notice that the last two, 7 and 8, have the same z-score, or the same score of 7 and 8, yet the z-scores are different. And this is because the variability is different. The variability in number 8 is less than the variability in number 7, therefore the z-score will be higher. Moving on to number 9 and 10, I'm going to add a workbook or a worksheet here, and then I'm going to add some data. So what we have is we have two samples here. We'll call them sample 1 and sample 2. Oops, I'll go back and type that in again. And I'll add in the data for sample 1, and down in the column. And we're asked to compute the z-score of a 16. If it were what is the z-score of 16 given this sample of data? So I'm going to calculate m and s, the mean and the standard deviation of the sample. Then I'm going to calculate the z of 16. So there, I've calculated the mean, the standard deviation, and now I'm going to calculate the z of 16. I'm going to take 16, subtract the mean, and divide by the standard deviation. And we have the answer there. For sample 2, I'm going to enter the data now. We have 10 scores in this sample, so it's a little bit different situation. But again, I'm going to calculate the mean and the standard deviation, and then I'm going to compute the z-score of 112. So if 112 were part of this distribution, where would it lie? I'm going to do something here, a little trick, and that is I'm just going to paste the functions, and I'm going to change the range to do the computations on the range that I want. This is a little trick that you can use if you don't want to type in all the formula over and over and over again. I'm just going to change this from 16 to 112. And there, we have our answer.